Good morning, my dear students. Welcome to this session on structural analysis 2. Let us see what we have discussed in the last session briefly, then we will go for the current session. So, the last session covers the circular arch geometry and then the parabolic arch geometry, and then we have gone for discussing the arch with springing points at different level, and then we have discussed about normal thrust and radial shear expressions derivation. And today in this session let us solve an example problem on three-hinged circular arches. So this is an example problem. Just go through the problem now. A three-hinged circular arch hinged at the springing and the crown points, which means these are the springing points. Let me take the highlighter. Right, this is where the hinge is present. This is where the hinge is present. So we will call these two. So let me take a color which is appearing. Right, this is the right one. Right, these two points we call springing points. This we call crown. Right. In the other way, it is a three-hinged circular arch. It means like that. Right. It has a span of 40 meters. This span of 40 meters. This is given here, 40 meters. And central rise 8 meters. The central rise right, okay, right, this is the central rise which is given there. This is 8 meters. Okay, so these are the properties given for the arch. So it initially says that it is a three-hinged circular arch. So your geometry is fixed. It is circular geometry, and it is a three-hinged arch, which means it is a determinate arch. And now coming to the properties, span is given 40 meters and central rise is given 8 meters. Then coming to the loads, UDL of 20 kilonewton per meter over the left half of the span, that means this portion where the load is applied, together with a point load of 100 kilonewton at the right quarter span point. Quarter span points means 1/4 of the span. So span is 40 meters. 1/4 of the span is 10 meters, either from either side. From this side 10 meters it is 1/4 point, and from right hand side also 10 meters. So this is one more point of quarter span. So quarter span points are there are two quarter span points. One is this one, another is this one. There are two quarter span points here. So what he said, point load 100 kilonewton at the right quarter span point. So this is the left quarter span point. This is the right quarter span point. So there 100 kilonewton is applied. Quarter span is nothing but 10 meters, because span is 40. You make it 1 by 4. Then what is asked? So this is the given data. So the given arch, what type of arch it is? It's a three-hinged arch. What are the properties? What is the span and what is the rise? And then what are the loads? So there are two loads here. One is UDL, another one is point load. Then what you need to find out? Calculate reactions at the supports. Then normal thrust, which means N value. Shear, which means a radial shear, nothing but Q, at section 10 meters from left support, nothing but 1/4 of the span, right? 10 meters from left. So this is a point where you need to find out all these like N and Q. You need these two values at this point. And calculate support reaction, means support reactions at A, support reactions at B. So this is a question what you need to calculate and what is a given data. So let's see how it is being solved. Right. First, taking free body diagram of entire arch. Remember, my dear students, first take free body diagram of entire arch. What does it mean? So this is the arch. Free body diagram means remove the support, apply the reactions. So this is a reaction here. This is a reaction, which means vertical reaction and horizontal reaction. You can name it according to your convenience. So you say VA here, maybe HA here. Similarly, the right hand side support also we remove, we apply reactions. So this is VB, and the other reaction is HB. So these are the reactions that you see when you remove the supports. That is what we call free body diagram. This is a well-known concept learned in the engineering mechanics of your first year study. Right, once you have the free body diagram of the full arch, now you see that this is a arch, which means a body acted upon by some loads. There are two externally applied loads and internal, which means developed loads. These are applied loads and these are developed loads. There are 4 point loads which are developed at supports, what we call support reactions. So considering the free body diagram of this arch ACB, so you can apply 3 equilibrium equations: sigma f x0, sigma f y0, and sigma m0. Let's see how it is being solved. So you may employ any of the 3 equations first. There is no fixed order for it. Means you need to apply sigma fx first, and then you need to apply sigma fy next. There is no such order. So it is according to your convenience. So I have applied first sigma m0. Then we pick a point, that means what we call moment center. So B is the moment center for me now. Either A or B or whatever known point for you, you can pick that point as a moment center. So B is a moment center for me. So I applied sigma m B0. So you take moments of all the forces acting on the arch about B and make it equal to 0. Okay. Sum of sigma means sum of all the moments of all the forces acting on the arch about B is equal to 0 is the equilibrium equation. So B is a moment center for me. Let's see how it is being calculated. So here is a point. B is a moment center. So if we see VA, uh, let's find out that I can increase this size of that pen color is there. Okay, no problem. Right. So HA is going to pass through this point, hence bending moment is 0. VA into L, that means 40. VA into 40 is written, you can see VA into 40 is written here. Then load 20 is UDL into span. Load span is 20 meters. From here till this point it is 20 meters. So 20 into 20 will give you point load which will act at the middle of the loading span, and you need moment at this point, so the load is acting here, so you need to multiply with this distance. Okay, so what is written now? 20 into 20 UDL converted to point load into the distance between moment center and the force is 30 meters. So that is written here. Okay, so this is 20 and plus 10, 30. Then now another load 100 into, this is straight away 10 meters distance. So you can see the directions. This is going to cause clockwise moment VA. Then UDL is going to cause anti-clockwise. 100 is anti-clockwise. And these two are at B, that this HB and VB are acting at B, hence you don't have any moment from those forces. So likewise, why we write plus and minus, so that you can apply some sign convention. So I written plus for VA into 40, which means I am taking clockwise as positive. It's your wish. So this whatever notation I have followed, so you can mention it here. So clockwise positive is written and anti-clockwise automatically becomes negative. So that gives you VA value, because only one unknown is present in this equation, which is VA is equal to VA is the unknown, that gives you the value of VA. Then going for, you have one more unknown VB, so that will give you with a simple equilibrium equation, sum of all vertical forces is equal to 0. So let's see how it is written. What are all vertical forces are there, you just see. So VA is vertical, VB is vertical, then 100 is vertical, and this UDL is vertical. Okay, so this is how the vertical forces are to be counted. So let's see VA, VB, both are upwards. So again, you fix the direction, maybe upward positive I have taken here. So VA plus VB and minus 20 into 20 minus 100 is equal to 0 is the equation. I have straight away taken these two values to the right hand side, hence there is equal to here. So it is actually VA plus VB, then minus it is 20 into 20, then minus 100 is equal to 0. This is actually the equation. Then if you take these two values to the right hand side, it becomes VA plus VB is equal to this. And then already you have VA value of 325, that you substitute, you will get VB value. So this is how we get the two reactions. You see, reaction at A is 325 kilonewton, whereas reaction at B is less, 175 kilonewtons only. Right. So this is by taking the total arch free body diagram. Okay. Right. So then moving on, because we are still left with two more unknowns, which is HA and HB, external reactions, I mean to say. So we have found VA value, which is 325, whereas VB value, it is just 175. Okay, so 325 and 175. These are the two values. Okay, right. Now you need to find HA, HB. So how do you do that? We have used only two equations, which is sigma m0 and fy0. So there are still two more unknowns left, and you need two more equations. Let's see how they are done. So by applying sigma fx 0, okay, let's see what this equation gives you. Sum of all horizontal forces is equal to 0. What are all the horizontal forces that you have in this arch? Only two horizontal forces. Horizontal reaction at A, HA, horizontal reaction at B, HB. And how do I fix these directions? Now you see, when you apply the load, this end will try to move outwards. This end will try to move outwards. So what this support will do is will try to stop. This is what is reaction. Similarly, this end also will try to move outward, because you are applying the load vertically downward, which means you are pressing in the other way. You are pressing this down, so the points, springing points, will try move outward as you are pressing the arch down. So it's very simple. You take a stick, bend it, then hold it with the two bottom points. Somebody, if they try to press it, and you feel that the ends are going away from the outward direction, so what you need to do, you have to hold it. So this is what is a reaction. This is what is a horizontal reaction. So HA, HB are pending. So there are only two horizontal forces now. So HA, if you take any one of the direction positive, maybe rightward positive or leftward positive, minus HB is equal to 0. So what it will give you, HA is equal to HB, which is equal to H. You come to know that which is a HA and HB are same, and both are same, and HA is equal to HB is equal to, you may call it as H. And now that is third equation we used. Okay, now What about the fourth equation? Because you can use for a free body diagram 3 equilibrium equations only. You cannot use fourth one. So how do you get that extra equation? Is by this. So whenever you find a hinge in any structure, it means that the bending moment should be 0 at that point. So you use that equation, additional equation, in the form of a hinge. So C is a hinge, so bending moment should be 0 at the hinge. So take a section at C, either take left part or right part, draw free body diagram. That is what is this one. From free body diagram of portion AC, you may choose any portion, maybe AB or maybe AC. So what I have taken is the AC portion. This what I have taken is this portion AC. So sum of all moments to the left is equal to 0. That is what I am going to use. Okay, sigma MC is equal to 0. Okay, so sum of all forces to the left of C is equal to 0. So what are all there on the left hand side? So you have 325 into 20. Now the moment center is C, so distance is 20. So 325, that means VA value. What is VA? 325 into 20. And you have UDL, which is already written, 20 into 20. Now the distance is 10. You have to observe this one. Here it is from the right hand support. Here it is from crown. Distance 10 is from crown. And now what is the other force which causes moment? So to the left of C, you have UDL, you have vertical reaction, you have horizontal reaction. So now H into the perpendicular distance is this one, 8. So H into 8. So only unknown in this equation is H, that is 312.5. So this is how you find the external reactions. Okay, so I'll just brief it once again. How to find external reactions in a three-hinged arch. Okay, it's very simple. First, take free body diagram of the entire arch. Full arch you take, draw its free body diagram. So you will find 4 support reactions, which is VA, VB, HA, HB. So you need 4 equations, but we have only 3 equilibrium equations that we will apply: sigma m0, sigma fy0, and sigma fx0. So all 3 we use, and we are able to solve only VA and VB with that, and by using sigma fx0, we will be able to know that the horizontal reactions are same and it is only H. Right, so this is what we are able to find out. So you are able to find VA value, VB value, and you are able to identify that HA is equal to HB is equal to some value H. And to find H value, you need to employ the fourth equation in the form of a hinge. So wherever you have a hinge, bending moment is 0, that you are going to use it here. So this is what is by taking another free body diagram, that is from free body diagram of either of the portions from the hinge, maybe to the left of the hinge, which means the crown, or to the right of the crown. So that if you take and draw a free body diagram and use sum of all moments either to the left or to the right of the section taken. So section is now at the crown. So you are using portion AC, means I am taking here the left part. Okay, so either to the left or to the right you may use. So that will give you the H value, horizontal reaction. Okay, so maybe next session we will go for the solution of the remaining half of the problem. That means how to find n value and how to find q value. Thank you all.